All right, baby, we are on to level 4. All right, now the previous ones were more or less straightforward. You could get the data directly from the information. You're able to just straight up calculate it. This one gets a little bit more challenging because this is a little more conceptual. All right, so it's going to be a lot less of getting numbers to put into equations, but this is a real AP question. This is one of the types that they like to ask, is where they have a couple of students make statements based off of a situation, and then you have to analyze their statements. All right, so go ahead, take just a minute. If you'll pause the video when I say no, then you can read through the statement. I'll hold it right here. You can read through it. Read through the two students, and then I'm going to go ahead and talk about student 1 and student 2. All right, so please pause the video now. All right, so hopefully you've had a good read through or you tried it on your own before. So I says which aspects of student 1's reasoning, if any, are correct. So student 1 says the distance traveled by the car and the truck is the same and the time is the same, so they must have the same speed. All right, well, what is correct? Well, the distance traveled by the car and the truck is the same. That's correct. They both went from 0 down to x equals d, right? They both traveled that same distance. The time is the same. Yeah, that's true too. All right, it took them the same amount of time to get from there to there. They were both here at the same time, and they both got to the house at the same time. So the time is the same. But this right here, this is not correct. They must have the same speed. Sorry, buddy. That is not correct. Why is that not correct? Well, what the student 1 did is student 1 used our definition for average speed. Okay? They took average speed, which is the total distance, over the total time. And so is the average speed the same? Yes, absolutely. But is the speed at this point in time the same? No. No, it's not. All right. Student 2, I don't see how that can be. The car catches up to the truck, so the car has to be going faster. All right. Well, yeah, the truck was moving fast, so the truck is in front, and then the car starts speeding up and eventually catches up to the truck. Now, in order for the car to catch up to the truck, it does have to be going faster. If you're going the same speed as the truck, then you're both going to be moving along at exactly the same speed, and the distance between you is going to stay the same. If you're going slower than the truck, you ain't catching him. He's going faster than you. He's going to get further and further ahead. All right? So, for the student 2 is 100% correct. The car catches up to the truck, and the car has to be going faster at that point. All right? Not the whole time, but at the point where the two vehicles are in front of the house, yes, the car's speed does have to be greater based off of this situation right here. All right, moving on to letter B. B says to derive an expression for the acceleration of the car and express our answers in terms of D and V. Well, now we're talking about let's solve for acceleration. So that makes me think about kinematics, especially since I'm talking about distance and speed and possibly some time here, right? So let's go ahead. We're going to go x naught, x, v naught, v, a, and t. So the initial position is going to be 0 right there. The final position is going to be d. The initial velocity of the car, right? We know that the car starts at rest, okay, because the car was stopped at the traffic light. So the initial velocity is 0. And then v is going to be, well, we don't know how fast that is. We don't know how fast the car is there. We're looking for acceleration. And unfortunately, we don't know how fast it's going either. So I guess we could leave this blank. I'll talk to you in just a minute about why I put the T there. Notice, well, okay, let's not put it there. First, notice that I only have 4 pieces of information. I don't have the final speed. So thinking about our equations, there's just not enough information there to be able to answer this question, right? With your three equations, x equals x naught plus v naught t plus 1/2 at squared, with your v equals v naught plus at, and your v squared equals v naught squared plus 2ax minus x naught. If you look at those, there's no way using x naught and x, v naught, to be able to solve for a. And able to solve for a, you're going to need that v, or you're going to need the t to use this one, right? This one also has the v. And so we need one of those two in order to be able to answer this question. All right, so what I'm going to do is, that was the car. So I'm going to see if I can do anything with the truck here. All right, because I also have information about the truck. Now, the other thing that leads me to think about the truck is this right here. It says, express your answer in terms of d and vt. What was vt? Well, vt was the constant speed of the truck. So the fact that that's the constant speed of the truck makes me think that somehow I need to connect the truck with the car. So let's see if we can do that. Again, the truck is going to start at 0. It's going to go to a distance of d. The truck starts at vt and ends at vt. And we actually know the acceleration. What's the acceleration of the truck? Well, the acceleration of the truck is 0, right? Because it keeps its same speed that whole time. So from there, we can actually solve for t. Now remember, we said that the time is the same. That's going to be important, because if I can find the time of the truck, I can find the time of the car. All right, so that's what we're going to do. We're going to go ahead and use the truck information. Notice that with the acceleration being 0, that kind of takes out a couple of our equations, right? This one right here isn't going to work very well, because if I put 0 in for a, then essentially I just get initial velocity equals final velocity. Yeah, we already know that. Same thing here. If I put 0 in for a, I get initial velocity squared equals final velocity squared, which, yeah, I know that. So those two are kind of going to kind of be out for the truck. So we're going to do the x equals x naught plus v naught t plus 1/2 at squared for the truck. So x is d, x naught is 0, plus v naught, which would be that vt, times the t, plus 1/2 times the acceleration, which is 0, times t squared. So this guy goes away, this guy goes away, and I can actually solve for t here just by dividing by the vt. So I get t equals d over vt. Now, AP loves this kind of question where they give you almost no numbers at all. We got a couple of zeros there, but really we don't have any numbers at all, and we're trying to solve for something using variable manipulation. This is why the first part of your summer work had a lot of math stuff, with just being able to rearrange equations and work with variables, because we are going to need that. So we're actually going to take this, we're going to put it in for t, which is d over vt. Now that we've done that, we should be able to solve for acceleration here. I still don't have the final velocity of the car, so let's take that guy out. If we take out the final velocity of the car, then we don't want either of these. We're actually going to go right back to the same equation, but now we're going to use it for the car. So for the car, we're going to have d equals x naught, which is 0, plus v naught t. V naught is 0, so that's going to be 0. I'm not even going to put down the t because I know I'm going to multiply it by 0 there, plus 1/2 times the acceleration, which is what I'm trying to find, times the time, which is d over vt squared. And so now we should be able to solve for the acceleration. So I'm going to multiply by the 2. That's going to give me a 2d. I'm going to multiply by the reciprocal of this guy right here. Now notice that the squared would go to the d and the vt, so that would end up being d squared over vt squared. Now to get it off of this side, I'm going to multiply by the reciprocal, which is vt squared over d squared. So those are going to cancel out. I'm going to do it over here as well. So I'm going to have vt squared over d squared, just like that. One of the d's is going to cancel out, and I'm left with a final answer that my acceleration is equal to 2 vt squared over d. Ta-da! We found the acceleration of the car. Now notice this didn't require anything other than what we've already learned. We're just using it in different ways. The math gets a little bit tougher because we had to look at both the truck and the car. Remember, it wasn't magic. We didn't just kind of have to come up with the truck. We thought about the question, the fact that they asked for our answer to be in terms of VT, which necessarily then said, oh, well, somehow I got to connect the velocity of the truck to the acceleration of the car. So maybe I'm going to look at the truck, and sure enough, that ended up helping us get what we needed. All right, so there's usually little things here that will help you get to where you want to go. All right, now the last piece here is letter C. Determine the time at which the speed of the car is equal to the speed of the truck. Express your answer in terms of TD. Now, TD, remember, is the time at which they've reached the house there. And there's a whole slew of different ways to do this, right? You can do it however you want. One way would be you could use your equations, and you could do something with, you could put VT into your equation, and we could solve for the actual time when that would take place. You could use the acceleration. In fact, I'll show you that here in a minute. You can also do it, though, through reasoning. Right? Through reasoning, if we know what the velocity of the truck is, which is constant, the car has to speed up, okay? And half of the time, it's going to be trying to get to that VT. So when half of the time is passed, the car is now going to match the truck. Now, the truck's going to be ahead of the car, but now they're going the same speed. But from now on, the car is going to continue to accelerate. The car is going to be faster than the truck so that by the time they get to D, they can catch up. By reasoning, we can actually infer that the amount of time, the time that it would take for the speed of the car to match the speed of the truck would actually be TD over 2, because half of the time it's going to be speeding up to get to that speed, and then half of the time it needs to be going higher than that speed, and it has to be split evenly in order for it to work. We can do other things with like graphing and stuff, but you know what? What the heck? Let's go ahead and show that we can actually answer this question using our kinematics, because hey, that's what we're doing here, right? So let's put in x naught, x, v naught, v, a, and t. Now t is what we're solving for. We're looking at the car here. We know the acceleration of the car is 2 vt squared over d. So I'm going to put that in, 2 vt squared over d. The final velocity I want to be the speed of the truck, so that's going to be vt. We know that the initial velocity is 0. We know that we're starting at x position 0. I don't know where this is going to happen. I already kind of talked about that I do believe it's going to happen halfway, right? At that halfway point, half the time it should work, but let's assume that I don't know that yet. We're just using the equations. This takes no assumptions, right? This is, we're solving for time. This is, we've got the acceleration. We just solved for that. That's constant. We're using the speed. We want it to match the speed of the truck. And so I don't actually need distance. So which of my equations doesn't have distance? So I'm going to take out this guy. I'm going to take out this guy. So I'm going to be left with v equals v naught plus at. And from here, I can just solve, right? I can put my final velocity there, which is vt. I can put my v naught there, which was 0. I can take my acceleration, which was 2 vt squared over d. And then I should be able to solve for t. When I do that, I'm going to multiply this over to the other side. I'm going to have d vt over 2 vt squared. That should hopefully equal t. One of those is going to cancel out, and I'm going to end up with d over 2vt is equal to t. I'm supposed to put it in terms of td, the final time, the amount of time it takes to get there. So we do know what the final time was, right? We discovered that here. The total time to get there was d over v dt. You'll notice that the time to get to the speed of the truck was d over 2vt. And so when we compare those two, we notice that this is exactly half of that. And so this is 1/2 of TD, which is what we said before, right? D over VT is that TD, the amount of time it took the truck to get to D. And so therefore, we get our final answer in terms of TD, which is 1/2 TD or TD over 2, which is exactly what we said before. All right, so there you go, level 4. This was a little bit more complicated. However, you can do it. It works, but it is a little bit easier to kind of think through it and reason through it. Again, the reasoning part will get easier as we discuss it more and more, and as we get some of those ideas and maybe some graphing under our belts, that should be much, much easier. But for now, again, like I said at the very beginning, we can accomplish all of these using the knowledge that we have. It does just get a little bit harder and a little bit harder. Level 4 is complete.